Alright, so now I'm going to start talking about how to solve first order linear differential equations. Now, first order means that you cannot have the second derivative or third derivative. You cannot have a higher derivative than the first one, okay? So you have to have something like this. Linear, that means that everything is going to be elevated to the power of 1. So if you have minus whatever, for example, a1, y in here, okay, all this stuff has to be, this a1 has to be linear. Everything is going to be elevated to the power of 1. And then you can have, for example, plus and whatever function, for example, function of x in here, all right? And this function of x has to be elevated to the power of 1 too. Anyway, okay. So that's a first order linear differential equation. Now, what is going to be the general format? The general format is going to be like this: y complement or y prime, okay, plus p of x y equals q of x. Now, what is p of x? Okay, p of x is a function of x, and q of x is another function of x. So this is the general format. Now, how do you solve this thing? Well, they came up with a very interesting idea. You know what they did? Look at this stuff in here. All right, here you have the derivative of y, and here you have a y without the derivative. So they were thinking, hey, this looks like this. Okay, let's just say that you have a function f and g. So you have f and g, and you take the derivative of both of them. It's going to be the derivative of the first times the second plus the first times the derivative of the second. So here, y is already in the right format, okay? And then you have this px multiplying the y here. Well, since the y is not being differentiated here, what's being differentiated is the second equation, okay? But you have to have this. It's the second function that's multiplying y that's being differentiated here. And then you have this p of x. So guess what? They came up with a very important thing, that e to the something, when you differentiate this stuff with respect to whatever, to the same something, it's going to be e to the something. So you know what these guys did? They created something called the integrating factor, okay? They said that they multiplied everything by the integrating factor. Now, what is the integrating factor? The integrating factor, we're going to call that u of x equals e elevated to the integral of p x dx. Now you see that this works. Now we're going to multiply everything here, so it's going to be e to the integral. Let me see here. You know what I'm going to do? I'm just going to copy this. I'm going to select this stuff. I'm going to copy it. Fine. Now I'm going to paste it down here, and then I'm going to multiply the y derivative plus p q, well, actually it's p of x, okay, y, and then I'm going to multiply this thing here, and then you have equals q of x and multiply it again, right? So nothing changed, you multiplied everything. But look at this. Let's just say that you have, what do you have in here? This thing here is going to be the derivative of what? Of the first function times the second function, okay? It's going to be the derivative of e to the integral of p of x dx, okay, times y, which is also a function of x, right, with respect to x. That's what this is. Because then look at this. We're going to repeat the first one and take the derivative of the second. So just differentiating this, we're going to say that it's going to be equal to this, right? Yeah, it's already right here. It's going to be equal to this, okay? Plus, the second one was differentiated. Now the first one has to be differentiated. So the second one is going to be copied. And now we're going to differentiate the second one. So you have e to the integral of px dx. So what is the derivative of this? It's e to the integral of px dx. It's the same thing. You repeat that. But then you have to multiply by the derivative of this function. Now you're integrating px with respect to x. When you differentiate, you go back to px. And you have to multiply by the derivative of this. So there you go. It's here, all right? And so that's what happens, guys. So this is going to be equal to q of x to this thing here. I'm just going to copy it. Okay, this is going to be equal to that. So what do you do now? Well, in order to find y, you're going to say that y equals, and now instead of writing this e to the integral of px dx, I'm just going to write ux. Okay. So, oh no, you got to integrate now, right? So you have that stuff. So the dx, you can get it out of here and put over here. And this, you just do that. You just erase it, okay? And now something else that you want to do is to, well, yeah. So now you have to integrate, okay? So when you integrate this stuff, this is the derivative of this with respect to x is this thing here, okay? All right, this is the derivative. So when you integrate this stuff, what are you going to integrate? You're going to integrate both sides, okay? And what you're going to be left with is e to the integral of px dx times y, because you just integrated this stuff, equals the integral of this. So you have the integral of q of x. I'm not going to integrate here, but you integrate it, okay? So you integrate this side because this was differentiating. So you integrate, you no longer have this integral here because you already integrated. So it's going to be the integral of this stuff, e to the p of x dx, dx again, okay? And now you're going to get this whole thing and divide by e to the integral of px dx. E to the integral of p of x dx. So you see what's happening here? You're not going to put this dx over here. You have to put it here. Why? Because you want this e to the integral of px dx, this final one here, to be outside the integral. First you're going to integrate and then you're going to divide, okay? Because, yeah, there's something else too, guys. This thing here is this thing here. Okay, so what I did was to get this stuff and move it all the way over here. So actually, I'm going to erase this here. This stuff no longer exists. So now you have the y. So you have y equals the integral of q of x times e to the integral of px dx. Okay, and then you have dx. You integrate this part, and after it's integrated, you divide it by e to the integral of px dx. This thing is the formula, okay? If you're going to consider e to the integral of px dx is equal to u of x, you say that y, when you have this, y is equal to the integral of q of x times u of x dx, and this integral, okay? You don't want to do it like this because otherwise it seems like you're integrating everything, and it's not. So what you want to do is to move this stuff over here a little bit further, like that, and you multiply like 1 divided by u of x times this integral. That's the thing. Okay. So I'm going to do some exercises now. So find the general solution of y complement plus y equals to e of x. Okay. Now let's see. If this is in the same format as that, it is. Okay. What is the px of here, or a p of x in here? It's just 1. Okay. That's the p of x. Is that a p of x? Yes, it is. 1 equals 1 times x to the 0. So it is a p of x. Equals to q of x. Okay, fine. So what do? We say that first you have to find the integrating factor, u of x. It's going to be e to the integral of px dx. Well, px is just 1, so dx. Here, that's the stuff. All right, and then now we say that y equals 1 divided by the integral, e divided by the integral of e to the integral, right, of dx times the integral of q of x, which is going to be e to the x, times e to the integral of dx. Right? This is the formula. Yeah, there's something else here, guys. You can already check. You can already solve for this thing here. For example, e to the integral of dx. What's the integral of dx? It's x. Okay. So this equals e to the x. Of course, when you're integrating dx, this is going to be equal to x plus c, right? But you don't have the c here now. So e to the x. Okay, so over here, you can just say it's e to the x, and here too. So you have an e to the x in here, and you have an e to the x in here. All right? And pretty soon you're going to understand what's going on. So this equals 1 divided by e to the x times the integral of e to the 2x dx, right? The whole thing, you got to put a dx in here. You got to put a dx in here. All right. So this is going to be equal to 1 divided by e to the x times e to the 2x divided by 2, right? All right, plus c. See, now the c showed up because you got to have a c in there if you want to have those initial conditions. So now the c showed up. So this thing is going to be equal to e to the 2x divided by e to the x is just going to be e to the x divided by 2 plus c. All right. Let me just think here. Actually, yeah, there's just one thing that I made a mistake in here. This 1 divided by e to the x is over here, okay? And when you're multiplying by the integration is this whole thing. So the c in here is also involved. So you have e to the x divided by 2 plus c times e to the divided by e to the x is the same thing as e times e to the minus x. Yeah, that's it. That's the final answer. Now another exercise. xy complement minus 2y, minus 2y is equal to x squared. Now, what is the first thing that you want to do? You want to put this in this format. So you want to divide everything by x because you want the coefficient here to be 1, okay? And you have an x. So dividing everything by x, I'm just gonna get this 2 out of here. I'm gonna get this x out of here. And in here, I'm gonna say minus 2 divided by x. All right, so now it's in the format. So u of x is going to be e to the integral of minus 2 1 over x. You know what? I just want to speed this up. So the integral of is going to be minus 2 of 1 over x dx equals minus 2 ln, oh man, ln of x. Okay? So this is going to be this stuff in here. The integral of this is going to be that. So it's e to the minus 2 ln of x. And there's something else that the book is doing. I mean, I would stop right here, but the book's doing something else. So it's doing minus, because you see, let me just do one thing here. Minus 2 times ln of x, you got to put this in the absolute value, equals minus ln of the absolute value of x squared. But x squared is always going to be positive, so we can get rid of the absolute value sign. So ln of x squared, okay? So I'm going to do that in here, minus ln of x squared. Okay. And now what is going to be y? Well, y equals 1 divided by, you see, 1 divided by u of x, right? That's what it is. But guess what? What is u of x? It's e to the minus ln. So 1 divided by this is just going to be e to the ln of x squared. All you got to do is to bring the denominator up, okay? Times the integral of q of x, which is x, times this stuff, times e to the minus ln of x squared dx. All right? Okay, so let's do that. It's going to be e to the ln of x squared times this derivative. Now, what is this derivative here? Well, times this integral. What's this integral? I'm going to open here parentheses, so it's going to be e to the minus ln of x squared, okay, divided by the derivative of this thing, right? And what is going to be this stuff is going to be times 1 minus 1 divided, man, it's so tight in here, 1 divided by x squared, okay? You know, I'm doing, there's something else that I forgot. Something else that I forgot. It's even simpler. Okay? The book is really good at simplifying these things. You have an e here and you have an e over here. So this whole thing, all right, is just going to be equal to that stuff over there. So you can say that, for example, this is actually 1 divided by e, right, to the ln of x squared. Now, you got an e here and you got an e here, so the whole thing equals 1 divided by x squared. So that's what I'm going to do. I'm going to say that this equals 1 divided by x squared. So y is going to be equal to 1 divided by u of x. So it's 1 divided by u by 1 divided by x squared. So the whole thing is going to be x squared times the integral of q of x, which is x, times u of x. Yeah, q of x, which is x, times u of x, which is 1 divided by x squared, dx. All right? So this is going to be equal to x squared. This is x to the minus 1 divided by, because you simplify this, right? So the integral of 1 divided by x with respect to x is just ln of x plus c. So c, this x squared times this stuff, okay? So this is just going to be equal to x squared ln of x plus c x squared. But hey, yeah, let me see here, find the general solution. Yeah, it's just to find the general solution. So what does this mean, general solution? Why is it general? Because you don't have the value for this c. For you to find the value for this c, you would have to find, for example, find y when something, for example, when x is 1, I don't know, okay? Let's just say that you were given a y value, let's call it y0, so y equals that, this is not true, okay? I'm just pretending here now. Y is equal to y0 when x equals 1. Well, this is going to be 1 squared 1 ln of 1. So this was going to be 0, so this stuff would cut out, okay? So the whole thing was going to be, yeah, when x is 1, was going to be y0 equals c1 squared. So c was going to be equal to y0, okay? And in here, you would put a big y0 like this. This would not be a general solution anymore. Now you have a particular solution. But because you have a generic c in there, this is the general solution. The book actually stops in here. It doesn't multiply it out. In here, several solution curves for c is equal to -2, -1, 0, 1, 2, 3, 4 are shown in figure 6.19. So I think this is interesting. That's the first time that I'm seeing something like this to show you guys a graph, okay? So these are going to be the level curves. For example, this curve, man, this is C4, 3, 2, 1, yeah, C0. So you see x and y along this one here, they're changing, but c is always going to be 0 in here, okay? And the c is always going to be 1 in this curve and 2. So you can see that it's like a family of curves. When you change the c from positive to negative, you start having some weird stuff in here. It's like this thing is peeling off. This looks like the shell of a banana, right? The peel of a banana skin, and you're just peeling it off. See? You peel it off here, and then here, and then here, and then this one here, the C0, starts to fall down, like it's falling like a leaf. And then you have c is equal to -1 in here, and then the c is equal to -1 falls even more down and goes like this, c is equal to -2. So this looks like a banana peeling. Okay, let's see if there's another one. Find the general solution of y prime minus y tangent of t is equal to 1. Okay. Minus y tangent of t. So now there's just something here, guys. You see that, yeah, and the t is gonna go, the t is being restricted, okay? It's gonna be greater than minus pi divided by 2 and less than pi divided by 2. Okay, so you can see that this is not dy dx, it's dy dt. Okay, t is the variable here, but you can see that it's the same thing. So in this case, what's going to be px? Px in this case is going to be tangent of t. and qx, which is actually qt, is 1, and px is pt, which is the tangent of t. Okay, so let's find, in this case, ut, right? It's going to be e to the integral of the tangent of t. Tangent of t dt. Okay, now I don't know if you remember this, but the tangent of t, you see, or there's something even better that you can do. Because you see, you don't want to get, here you have a y, and here you just want to have a y too. So it's actually a minus, okay? Because you carry the minus tangent of t. But instead of integrating with respect to the minus tangent of t, you do minus elevated to the minus integral of the tangent of t. Now, I don't know if you guys remember this, but the integral of tangent is going to be equal to the minus ln of the cosine. Cosine of what? Well, in this case, it's going to be the cosine of t, okay? And this thing is between t is equal to minus pi divided by 2 and pi divided by 2y. Let's make this over. Let's do this here. All right. So the cosine of t has to be positive. Where is the cosine of t going to be positive? In this part here, in this half of the circle. Okay. Everything here is negative, but you cannot have the negative because e elevated to whatever here cannot be something negative. It has to be positive. So cosine, and they probably don't want the cosine of t to be 0 because t is greater than minus pi, and minus pi divided by 2. Minus pi divided by 2 is here, and pi divided by 2 is here. So at these points, the cosine is going to be 0. You don't want that. Okay, so since it's a minus tangent of t, this is going to be a plus. Okay, so it's ln cosine of t. So this equals e to the ln cosine of t. But guess what? Again, this is an e, and you got an e here. Okay, a hidden e here. So the whole thing equals to the cosine of t. All right? This equals the cosine of t. So the cosine of t is u of t. All right, so let's do this. Y equals 1 divided by the cosine of t times the integral of 1, right, which is the qt, times u of t. So it's just going to be the integral of the cosine of t. And you have a dt, dt. All right. Well, this thing is just going to be 1 divided by the cosine of t times the integral of this is the sine of t, right? But remember, it's the sine of t plus c. So you have to divide this whole thing here. It will be like equals sine divided by the cosines, the tangent of t, plus c secant of t. Because it's going to be c divided by the cosine, the reciprocal of the cosine is the secant, so there you go. That's the general solution. Yeah, it's just what the book is asking for. And that'll be it for this video, guys. I'll see you on the next one.